Bismillahirrahmanirrahim. Exercise 7.2, question number 10, part C. Find a vector of length 5 and in the direction opposite to that of this vector V. So we start the solution. And first of all, we are going to find the magnitude of vector V. Then we will evaluate the unit vector along vector V, and then we will find the required vector. So we start the solution. Here the vector V, given vector V is equal to I minus 2j plus 3k, and then its magnitude. It becomes square root of unit coefficient of I is 1, so 1 square, plus coefficient of j is minus 2, so minus 2 square, and coefficient of k is 3, so 3 square. So it becomes 1 plus 4 plus 9. 9 plus 1 is 10 and 10 plus 4 is 14. Hence, the magnitude of this vector becomes square root of 14. And now, a unit vector along vector V will be equal to the vector V divided by its magnitude. So, I get the vector V is I minus 2j plus 3k whole divided by square root of 14. As a result, I can write it as 1 by square root of 14 into unit vector I minus 2 by square root of 14 into unit vector j, and then plus 3 divided by square root of 14 into unit vector k. So this is a unit vector along the given vector V. Now the required vector, which is of length 5 and its direction is opposite to that of vector V. What will be this vector? The required vector with unit vector, a vector with magnitude, a vector with magnitude 5 and opposite to vector V is equal to minus 5 into unit vector V. So just put in the value of unit vector V, minus 5 into 1 by square root of 14 into unit vector I minus 2 by square root of 14 into unit vector j plus 3 by square root of 14 into unit vector k. As a result, it becomes minus 5 by square root of 14 into unit vector I plus 2 into 5 is 10. 10 by square root of 14 into unit vector j minus 5 into 3 becomes minus 15 by square root of 14 into unit vector k, and that is the answer.